Hey everyone, so if you're building with AI, you already know how incredibly powerful large language models are. But, and this is a big but, are we actually using them in the smartest way possible? Today, we're going to dig into how you can build AI products that are more efficient, way more cost effective, and a whole lot more reliable.
And I want to kick things off with this piece of advice because it is so important. We've all seen those jaw-dropping AI demos, right? The ones that honestly feel like you're watching magic happen. Well, the source material for this explainer warns us. Don't draw the wrong lesson from these demos. So what is that wrong lesson, and how do we avoid it? Let's get into it.
Here's our game plan. First, we're going to talk about something called the AI demo trap. Then, we'll pull back the curtain on the hidden costs of just throwing an LLM at every single problem. After that, we're going to say hello to an old friend, simple code. And finally, we'll see how all of this comes together to build a much smarter, high-break future.
All right, let's jump right into part one, the AI demo trap. You know the demos I'm talking about, things like OpenAI's Agent Builder, where it all looks so effortless. But what we're going to see is how these dazzling displays can sometimes teach us some, well, pretty bad habits when it comes to building for the real world.
Okay, so take a look at this. This is a classic example from one of those demos. A user types in, "Plan my trip to Paris," and the AI agent, seemingly on its own, decides to break that down into two distinct tasks. First, build an itinerary, and second, look up flight info. It looks like the LLM is making this really sophisticated, intelligent routing decision. And you know what? In the demo, it is. But this is the million-dollar question, isn't it? Does every single step in that chain, especially that very first decision to go down path A or path B, really need the full power, the full cost, and the full complexity of a massive language model? The answer is a hard no. And that question leads us perfectly into our second section here, because falling for that demo trap has some very real and often hidden consequences once you try to move your project from a cool proof of concept into a product that real people are using. When we get into the habit of overusing LLMs, there are three major hidden costs that can just sneak up on you and quietly sabotage your project's budget, its performance, and maybe worst of all, its reliability. Let's break them down one by one. First up, the most obvious one, cache. Every single time your application calls an LLM API, you are paying for tokens. It's that simple. Using a super powerful model to make a simple routing decision is basically like using a sledgehammer to crack a nut. It's complete overkill, and it directly hits your bottom line every single time. Next up is speed. Every call to an LLM takes time. We're talking about inference time, and those milliseconds, they add up fast. A workflow that makes a bunch of unnecessary calls can feel incredibly sluggish to your users. And let's be honest, in today's world, speed isn't just a nice to have, it's a core feature. And this one is huge, unpredictability. LLMs are, by their very nature, probabilistic. That means they don't always give you the exact same answer twice. This can lead to all sorts of weirdness, like hallucinations or just completely unexpected errors. And trying to debug a system where every step is a mysterious black box, it's an absolute nightmare for developers. In this quote from the source just hits the nail on the head. It perfectly captures the core issue. LLMs can hallucinate. Code doesn't. You might get a bizarre result from an LLM, and good luck figuring out why. But with code, an error leaves a trail. You can trace it, you can find it, and you can fix it. It's deterministic. So what's the solution here? Is it some brand new, even bigger AI model? Nope. It's actually something we've had in our toolkit all along. In this section, we're going to rediscover the incredible power of simple, reliable, good old-fashioned code. Just look at this comparison. It makes things crystal clear. When you look at accuracy, code is deterministic. It's going to do the exact same thing every single time. In terms of cost, you write the code once, and that's it. You're not paying per token for the rest of its life. And for debugging, it's traceable and fixable, not some opaque black box. For these simple, repeatable tasks, code is just the better tool for the job, period. So let's circle back to our travel assistant example. Instead of using a pricey LLM just to decide between build itinerary or find flights, what if we used a simple if-else statement that looks for keywords? It would be faster, it would be cheaper, and it would be 100% reliable. The humble if-else statement is truly the unsung hero here. And that's exactly why this quote is so resonant right now.
The hype around AI can make it feel like we need to throw out everything we've learned about programming, but that's just not true. Those foundational principles, they're actually more critical now than they've ever been.
Okay, so for our final section, let's pull all these ideas together into a really powerful new strategy. Because this isn't about choosing code instead of AI. It's about creating a smart, hybrid future where we use the absolute best tool for each specific job. And here it is, the philosophy in a nutshell. The smart hybrid approach. It's a strategic mix. You use your boring, reliable, deterministic code for the simple, straightforward parts of your workflow. And you save the powerful and, yes, expensive LLMs for the tasks they were truly built for, things like complex reasoning or making sense of messy, unstructured data. So what does this actually look like in practice? Well, it's pretty simple. You save your LLMs for the really heavy lifting, true reasoning, searching through documents, or analyzing sentiment. And you use simple code for all the predictable stuff, routing users, doing math, and any step that absolutely, positively has to be reliable every time. And why do we do all of this? Why go to the trouble? Because when you move beyond a flashy demo and into production, you're playing a different game. You're building a real product where things like cost, speed, and accuracy are what actually determine whether you succeed or fail. So I'll leave you with this one question to mull over. As you start building your next AI feature, just ask yourself this. Are you designing for demo day flash, or are you designing for real-world function? Building truly smart, efficient AI is all about knowing the difference. Thanks for tuning in.